Thank you for joining us for our J-Series water-only webinar. As we're going along, if you have any questions, please type them in using the question mark icon on the right side of the GoToWebinar window. We'll answer those at the end. Due to the large number of people we typically get on these webinars, if we don't have time to answer your questions, we'll get in touch with you after the webinar. I'm currently in our Customer Technical Center in Tallmadge, Ohio, where we have several water jets and routers set up for test cuts and demonstrations. This facility is also where we build all of our water jets, and we've got about 90 employees here for engineering, support, and manufacturing. I hope you can join us here someday for a visit to check out the facility. Behind me is our J106 water-only water jet system. This has a 6-foot by 10-foot cutting area, or 1.8 meters by 3 meters. This machine has a 10-foot loading area and a 6-foot offloading area. It also has one continuous stainless steel chain to move your material through your cutting area. The J128 is another standard model, which has an 8-foot by 12-foot cutting area, or 2.5 by 3.6 meters. The J-Series machines can be tailored to suit your application, whether you need a larger cutting envelope, longer loading or offloading tables, multiple heads, separate chains, conveyors made out of different materials, and so on. Here's an example of a machine that we'll start building soon. This machine has an 8-foot by 22-foot cutting area. The loading and offloading areas are also over 22 feet long, and the conveyors in those areas are a rubber belt material. With that, we'll go ahead and zoom in on some of the other features on this machine and see what really sets us apart in the water-only market. Down here at this end of the machine, this would typically be where you feed your material into the system. That's one of the great things about the J-Series. You can either use it to cut planks of material, or you can cut rolls of material. If you're going to be using it to cut only planks of material, you don't need the pinch feed roller that's shown here. But when we do a roll, the pinch feed roller will come down, pinch the material, and help pull the material into the cutting area. Looking at safety, we have this cover here. If you're running the chain backwards and material gets under that cover will flip up and put the machine into e-stop. Next, we have this optional safety guarding here. There's an access door on the other end for access into your cutting area. That door is interlocked. If anybody tries to enter the cutting area while it's cutting, everything's going to be put into e-stop. Another safety feature is we have several e-stop buttons like this around the system. There's one on the controller, as well as each corner of the machine. Also, it might be a little bit hard to see on the video, but we've got polycarbonate side guards here. These are standard. It's got the ones across the top here so people can't reach over the drive system, and then also down here so you can't reach into the cutting area. I think you'll agree that we've really addressed the safety issues of working around a high-speed machine like this. Now back down here at the loading end of the machine, we've got this control box here. We have 4 control boxes around the machine. This one has a few more functions than the other 3. We'll take a look at those in a moment. This one back here, we've got this switch here that controls how far down that pinch feed roller is going to come to pinch your material. So you can use this to raise or lower that. And then to actually bring the pinch feed roller down, you've got this switch here. Just switch that. That'll come down to that height that you've set. Got a button here for loading your material. Press that and the chain will advance your material, and when the front of your material hits the photo eye at the front of your cutting envelope, then the chain will stop. Also got switch here if you manually want to jog the chain backwards or forwards. And then you've got a start button and a stop button. These buttons can be programmed to work the way that you want them to work with your production requirements. So for example, the stop button can be programmed such that it'll either stop the machine right away, or it'll stop it at the end of the next part or the end of the program. So let's take a look at the other 3 boxes and see what's on those. The other 3 control boxes on the machine are like this one here. You've got the load material button again, the manual chain jog button, e-stop, start and stop program. A couple of other features to point out at the loading end of the machine. First of all, we've got chain guide here. There's also one on the other side underneath the material guide. Chain guides keep your chain going nice and straight through your cutting area. It's particularly important if you're cutting a part that's longer than your cutting envelope and you want to be able to index your material and pick up and continue that part. Those chain guides will keep that chain going nice and straight through the cutting envelope and also your material. And then over here on the right, you've got the material guide. So when you're loading your material, you can butt the edge of your material up against that, and that'll keep that true to your cutting envelope. Now let's take a look at some tank design features. From this perspective, you get a good view of the tank construction. You'll note the sloped bottom design to the tank, so all your cutting water is going to drain to the middle and then go out one of the drain openings. The tank is designed with a drain opening on either side of the tank, so depending on how your machine's installed in your facility, you can have it on either side. Since this machine has the right side of the machine against the wall, we've got the drain opening on the other side open. If the machine's going to be installed such that the left side of the tank is against a wall, then you open up this one, close the other one, and then the water will drain out from there. And we'll go around the other side and take a look at the drain on the other side of our tank. First thing I'll point out is that the floor of this tank is 1/4-inch stainless steel. That'll maximize the life of this tank. So as that cutting water is coming out, it's going to wash out some of the debris of the material that you're cutting there. So that's what we've got here. Top of this sump tray, we've got this expanded mesh screen here to catch a lot of that debris, and then water will flow into the sump tray. From there, you could take your own sump pump and pump that water to drain. You might want to pump it through a sock filter to get any more of this residue out of the water before it goes to drain. Another option would be you could pump to one of our optional paper bed filters. We'll show you that here in a moment, and then go to drain. So the paper bed filter will do a good job of filtering this out of your water also. And then another optional item is we've got washdown bars inside this tank. That's what these hoses here are connecting to. There's one here, one there. We've got some proximity switches on the tank here, so when the water level hits the proximity switch, diaphragm pump on the paper bed filter will turn on, pump water to the paper bed filter. Water goes through the paper, filter out the water, and then excess water can be pumped back through the hose to those washdown bars to wash more of this debris out of your tank and keep that tank cleaner. And then ultimately this opening here is big enough where if you do get debris build up in there, you can get a rake or whatever in there to scrape out whatever might be building up. So now let's take a look at the paper bed filter. Here we've got that optional paper bed filter. Down below we've got the diaphragm pump. We'll pump that water from that sump tray over to here. Comes out here, flows down. There's filter paper in there. The micron size of that filter paper can be tailored to your application, the materials that you're cutting. That filter paper will slowly advance, collect in the tray at the end there. New roll of filter paper goes in up here. And then you'll have cleaner water going to drain, and if you purchase the optional washdown bars inside the tank, we can pump some of that water back to those washdown bars to help spray out the tank. The drive system on this machine is a helical rack and pinion. The aluminum crossbeam on the J106 comes in at 159 pounds, which is about 70% lighter than the previous version steel crossbeam that we used to use on this machine. The combination of the helical rack and pinion and the lighter crossbeam allows us to achieve speeds of up to 2,500 inches per minute or 63.5 meters per minute, with an acceleration of up to 80 inches per second squared or 2 meters per second squared. This machine has 2 Z carriages. The number of Z carriages on your machine can be tailored based upon things like part size and production requirements. The Z carriages can either be manually or CNC controlled when it comes to spacing. This machine has manual spacing for the Z carriages. The up-down motion of the Z carriages can also be either manual or CNC controlled. This machine has programmable Z motion. Programmable Z can be used to move the cutting heads to the correct cutting height at the start of a program based upon the thickness of the material being cut. Also, if we're cutting with multiple heads, We check the Z position of the cutting heads at the start of the program and level the additional heads to the same Z position as Z1. The J series can have 2D, 5-axis, or a combination of those heads. This machine has our Apex 60 5-axis head on Z1 and a 2D head on Z2. Spreader bars can be used to mount additional 2D heads to further increase production. Now, let's watch some loading and cutting.
We'll run through what iGEMS can do for multi-head nesting and common line cutting now. So on the screen I've got some parts that will be nesting, and then these rectangles here represent the overall length of a roll of material that I'll be nesting these on, and each of these smaller rectangles represents the cutting area of the machine. So it'll nest into one area, and then when it's done cutting that, it'll index the roll of material forward and we'll cut in the next zone and so on. So on this roll of material, if I know that the first few inches of my material are a little bit chewed up, I can set up a dead zone at the beginning of the roll here that's not going to nest parts into, and then you can also have a zone here on the side of the material that you don't want to nest into. So on our nesting tab, I'll click our auto button and select the parts that I want to nest, and then we'll nest it onto the roll of material. In this screen here, we've got the quantity of parts that we're going to nest, and then over here on the right we can tell it how many cutting heads we want to use, and whether we want to use constant head spacing if we have a machine that has manual head spacing adjustment, or if you have programmable head spacing, you can choose the dynamic option, and then the head spacing can change throughout the nest. And if you choose constant, you can choose this distance button here, and it'll set this distance to be half of whatever the usable width of your piece of material is. And then you've got checkbox here whether you want to do common line cutting, and you can optimize that based on either time or material or an average, and then minimum length of a line that you want to do common line cutting on. So we'll go ahead and click on nest, and it'll go through several different layouts. The red lines represent areas where it's seeing that it can do common line cutting. So you can let this go for a minute or so. Once you're happy with things, you can click on the stop button and then OK. And then at this point we can go to our CAM tab and click on our toolpath and then common command. And if I am doing a roll of material, I'll just add my toolpath onto each of these cutting zones individually. So I just drag a box around each of these zones here. So the green parts on the left are being cut with head 1, and then the gray parts on the right are being cut with head 2. Once I've got my toolpath, I can click on my order button, drag a box around the parts, and it's going to start with the bottom sheet and then work its way up. The numbers in brackets indicate that these are being cut with head 1 and 2. And then at this point click on the process button, and then you can make your CNC file. So at the beginning of the program here, we see we've got heads 1 and 2 turning on, and a little bit of common line cutting there. And then when it gets to the end of that, it's going to index that sheet forward and then start on the next cutting zone. A couple other things you can do if you have a, say for example, an odd number of parts. I'll just go ahead and draw a part in here. Click on my order button, select my cut order, so I can add a part to that cut sequence. And right now this will be cut with head 1, and then I can just put that into my proper sequence on my nest there. If I put this part onto this side of the sheet and I click on the order button to add that to my cut sequence, click on this plus button again, select the part. So right now, again, it's showing in brackets that it's going to be cut with head 1. If I check this zone detection box, click on zone detection, then it'll change that to being cut with head 2 because it sees that it can really only be cut with head 2. You can also do things like if you have a part that's needs to be cut with both heads 1 and 2, you can do a manual toolpath on a part. If I go ahead and just create a part out of this, so I can use my manual command, so toolpath manual, and then 0 point, I'm just going to pierce at the middle of this part here, and then I'm going to have it go halfway around in this direction, and then I can do a second toolpath where I'll start up here, and I'm going to go around back down to here and go in that direction. And I can use the tools button up here to tell it which tool I want to use for each of those tool paths. So if I choose tool head 2, click on apply, I can choose that tool path there. So the first part of that will be cut with head 1 and then the second part with head 2. And again, I can click on my order button to add that to my cut sequence. So use my plus button here. We'll see here that's cutting the first part of that rectangle with head 1, and then the second part of it with head 2.
In WardCam, we've added some capabilities to be able to program 2 heads. So an example like this, we're going to cut these 2 rings with head 1, and simultaneously we'll be cutting these 2 rings with head 2. This ring on the end here, a little bit too far for head 1 to get over there. We don't have enough material for 2 rings, so we'll just cut this ring with just head 2. This rectangle we're just going to cut with head 1, and then this longer rectangle, the left half of it will cut with head 1, and then the right half of it will cut with head 2. One thing to note on this one here is when I drew this in CAD, drew this such that it's going to end up being open contours where there's an overlap here. Make sure that we get good separation, so this can be quarter of an inch or so, and we'll be able to program that as 2 separate cuts then. So what we'll do here is we're going to draw some points in here, and these are going to be points that I can use to tell WardCam different things like what my head spacing is going to be. So these 2 points here I'm going to use to figure out what the head spacing needs to be on this layout, and then I can put in additional points where I want to switch between different head configurations. So this part here, we only cut this with 1 head, so I'm going to put a point here that I'm going to use as a reference to tell that I want to use head 1, and then when I want to switch to just cutting with head 2, I can just put another point somewhere up here, and we'll flag that as being just for head 2, and we'll cut these last pieces here with head 2. So once we've got that, we can go ahead and hit our next button. So over here in the point functions, got some new point functions here, distance, h1, h2. So if I click on this point that I put in here and this point, then that's what we're going to use to find out what the head spacing needs to be for this layout. And then I can tell it what parts I want to cut with heads 1 and 2 simultaneously with the head 1 and 2 option here. So I'm going to click on this point here again. Up here in my cut sequence now, I've got the head 1 and 2, so now I can add the cuts that I want to be with both heads 1 and 2. So I'll go to my next step in my process here, and I'm just going to add the tool paths for these 2 parts here. And since I told it that I'm doing head 1 and head 2, these 2 parts will be cut simultaneously, and I don't need to add a tool path to those ones. So I can go back to my prior step, and now I'm going to switch to just head 1. And I'm going to make that change at this point here. Again, adds it to our cut sequence here, and we can go to our toolpath screen again. We're going to add a toolpath to this one here, and then if we go back on the parts area, I can use the open contour cutting to add my cut for this half of this rectangle here. So if I just left click when this part of it's highlighted, then it's going to cut this outside contour, and then it's going to cut that half of the rectangle. And then I want to swap to cutting with just head 2, so under my point functions, choose head 2, and I'm going to make that change at that point there. And I'm going to do my open contour cut for the second half of that rectangle, so left click to add that to my toolpath, and then hit my next button and add a toolpath to this. So now we've got from the top here, we're establishing our head spacing. We're telling it want to use heads 1 and 2 on these cuts here, and then we want to switch to just head 1 for this contour and then we want to switch to just head 2 for that and for the final ring there. So with that, we can hit our next button, click on the CNC button. So in the code here at the beginning, we have a comment for the operator. So if you got manual head spacing, they'll set their heads to basically 20.5 inches apart. If you have automatic head spacing, then we would put a code in there to automatically set the heads to that distance. And then it's going to be cutting here with heads 1 and 2. So this M60.0102 tells heads 1 and 2 to turn on simultaneously. And then we'll switch to cutting with just head 1. So we have the M60.01 just for head 1. And then we'll make the switch to head 2. So we've got the cutting here with the M60.02 for head 2.
In my veins, I've been driving this train, years in this lane, there's no stopping this flame, cause I came to the game and I changed it to play how I like, rearranged it to my own domain. Yeah, I got what it takes, made lots of mistakes, taking shots, skipping breaks, feeling lost, feeling great, popping off, singing straight, never stopped, never changed, all the squad here to play, and I've got something to say, yeah. I work hard each and every day, I get lost in the words I say, I don't push pause, no I push play, I won't stop till I make a change. I withdraw on the things I make, I turn flaws into flawless traits, I build tall, never capped in space, I won't stop till I hear him say, oh, oh, la, 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 la.
Thank you for joining us for this webinar on the J-Series. Hope you enjoyed it. I ran that nest 2 times, about 33 minutes of total process time. As you can see, large number of parts in that short amount of time. J-Series is an incredibly productive machine. Now let's see what questions we've got.
I won't stop till I make a change. I withdraw on the things I make. I turn flaws into flawless traits. I build tall, never capped in space. I won't stop till I hear him say, oh, oh, la, 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 la.
Hopefully you're all seeing my screen now. If you do have questions, go ahead and type them into the questions box, and hopefully we'll have time to get to them. First thing I will mention is we are offering a discount on the J-Series machine that we just saw. So in the NAFTA region, $25,000, 20,000 pound discount on J-Series machines in the UK. So you can go to our website, get more details about that if you like. Contact our sales department if you like more details. Usually I like to do a little quick tour around our facility just to show you what's new if you've been on one of these before. I always mention each time it's going to be a little bit different array of parts, machines that are coming through the factory here. So we've got a couple A-series, smaller A-series machines in the background being built up. We've got a X-series abrasive machine set up here, wrapped up, ready to go. And then over here, we've got a couple of X-series machines that are being built up and nearing completion, looks like. And if we go to the other end of that bay down here, pan a bit to the left, we've got a J-series machine that's actually being built up. We just shipped one last week. We've got a series of J-series machines that are going to be coming through the factory here over the next couple of months. So this one looks to be also about a J. Not sure if that's actually a 10.6 or 12.8. It's got the loading, 10-foot loading, 10-foot offloading tables, and then that'll be put together and have the chain put on there. And then in the background, we got our new M series machine that you may have seen if you joined last month's webinar. And let's see, we got our circuit board room, which looks like quiet today, but this is where we make all of our circuit boards. So we make all of our own circuit boards, which allows us to design things to be backwards and forwards compatible. And we've got our welding, and it's our machining center, our Cincinnati mill. I've got a couple tanks here that are ready to go off to paint. And let's see what else we got. We've got a couple other tanks that are being welded up here. So basically material comes in the back and goes through welding, goes out to paint, comes back and completed. Whole A series machine. So, and then on the other side there, we've got our Giddings and Lewis mill, 5-axis mill. And then we've got our various Haas machines, VF12. We've got a new slightly used VF4 down here we just installed, and then the VF2. And then in our demo area, looking at our demo area, we've got actually components for another J series machine, the next one to be built up here in the background. So, all right, let's work through some of our questions here. So first of all, in the video, I noticed that the material looks to have gone past the photo eye and then stopped. Can you explain what was going on there? Don't know if I can pull that up in the video, but that photo eye is basically set so the such that the front of the material trips the photo eye, and then based on the speed and acceleration of that chain, we can then tell the chain to stop at a specific location. So that photo eye is not set up at what would be the Y0 position on your table. It's set up about 12 inches before that. And then we can adjust the machine acceleration and speed so that that material stops right where it needs to basically every time. So that's why that material goes beyond that photo eye a bit there. And this question about, let's see, I'm cutting very thin, lightweight material. Any idea how cutting on the chain will affect this? Well, ultimately, we can do some test cuts if you want us to check it out. We do offer different support options other than just chain. So for example, on our website, we show some different options for the grates. If we go, I believe, under the water jet grates area. Another popular option is water bricks like this. So if you are cutting very delicate material that might not react very well to the chain, you can buy a machine that's filled with water brick like this, or if it's just something you do periodically, you could buy a tray, maybe 4 foot by 4 foot tray that has these water bricks in there. And then when you need to cut that material, you can put it on here. And this usually gives nice support to very delicate materials like that. And then probably a good time to mention that we also do machines other than chain systems like the J series that we're just looking at. The water only cutting area can show some different options also. So the shuttle table system like this is also popular. And this also works well with the water bricks. So you could fill both of these tables with water brick or whatever other support might work best for your material. And then let's see, how many parallel cutting heads can be installed on a single machine? So that ultimately depends on your part size and configuration. We've got one customer that cuts very long, very narrow parts, and they have 16 cutting heads installed on their crossbeam. It's obviously a bit extreme. Most water-only systems that we go out will have at least 2 heads. A lot of them will have, like in the picture here, 4 heads. So that's one of the things we look at during the sales process is your part size and what's the optimum number of heads for the parts that you're cutting. And then of course, in conjunction with that, we also have to look at the size pump and orifice that you're gonna use to cut your materials. So, because the next question is, how fast can I cut 6-pound foam? So fortunately, that question was asked fairly early on in the webinar, so I'm able to pull up a couple pictures here of some test cuts that we've done. So you can drag this over.
So this would be 6-pound foam cut with a 7th thou orifice. So for those of you that aren't familiar with it, I'll just briefly show. Go to my slide sorter here. Probably the easiest way to show this. The orifice is on the water-only head mounted down here in the bottom of the cutting head, and this changes your pressure to speed. And the size of this orifice can be anywhere from 3 or 4 thousandths of an inch up to 14 thousandths of an inch. Typically for water-only cutting, people will use these at 7th thou or 10th thou orifice. So these are some cuts done with a 7th thou orifice at these different speeds here. And then same material, 10 thousandths orifice, same type speeds. So a little bit more, you basically have twice as much power with the 10 thousandths orifice versus a 7th thou. So as you get thicker and denser, you'll move more towards the 10 thousandths orifice, and thinner and lighter materials more towards the 7th thou or even a 5th thou orifice. So there's a lot of parameters that go into optimizing water-only cutting, which makes it pretty interesting when we're doing test cuts, because we do have to balance the size of the pump with the number of heads and the size orifice that you want to use. Let's see, during the video, looks like you showed 2 different software packages for programming. What was the difference between those 2? Yes, the first one I showed was the optional iGEMS package. iGEMS is a full-featured third-party package that does offer full true shape nesting and common line cutting, and it's very powerful, very easy to use. WardCam is a package that we supply with the machine free. You can have unlimited seats of WardCam. A little bit more limited in that it doesn't have a nesting package. Common line cutting is not quite as easy to program as iGEMS, but it's great for doing single parts, or you want to bring a nest in with a bunch of parts that you manually nested together, and maybe in CAD, or you've got a third-party nesting package. You can nest that, bring the DXF file into WardCam, and with a couple clicks, add your toolpath. It doesn't have quite all the power of the multi-head cutting that the iGEMS has. We have added some features in there that I showed in the video for WardCam if you do want to do multi-heads, but nice thing is it's included and it's free, and you have unlimited seats of WardCam, so that's always nice. And let's see, how long will the chain last? Will the chain get cut up with the water-only stream? No, so the water-only stream has relatively small amount of power, obviously enough power to cut through your materials, but it's not going to cut through the chain. So that's of course why we use the chain, is it's not going to be cut by the water jet stream. So looks like we've gone over our time here. So these other questions that have come through, I will answer these offline, but do appreciate your time and hope you found this interesting. And if you do have any other questions, please feel free to email sales@wardjet.com. Thanks for your time.